Imagine arriving in a city where your phone unlocks a bicycle, pays for breakfast, calls an electric taxi, and guides you into a railway station the size of an airport. Minutes later, a train accelerates beyond 300 kilometers per hour. Outside the window, apartment towers, solar farms, factories, and entire new districts pass by in an almost continuous landscape. Nothing feels experimental. Nothing is presented as a futuristic demonstration. It is simply Tuesday morning in China. That may be the most unsettling part of China's technological rise. The machines themselves are impressive, but the real shock is how ordinary they have become. For years, Americans were told that the future would be defined by electric vehicles, automated factories, high-speed transport, intelligent cities, and clean energy technology. America helped invent many of those ideas. But China built something different. It constructed the industrial ecosystem required to manufacture them, improve them, lower their cost, and deploy them across an enormous population. That is why some American executives, engineers, and travelers now return from China with an uncomfortable observation. The competition is no longer about who can create the most exciting prototype. It is about who can turn tomorrow's technology into today's infrastructure. And in several critical industries, China is doing that at a scale no other country has matched. Before we continue, subscribe for more premium documentaries about technology, global power, and the forces reshaping our future. Because the story of China's rise is not only about China. It is about what happens when one country becomes extremely good at building, while another becomes extremely good at debating what should be built. Let us begin with the most visible symbol of this transformation: China's high-speed railway network. At the beginning of this century, China had no modern national high-speed rail system. Today, its network stretches for tens of thousands of kilometers, connecting giant coastal cities with inland manufacturing centers, provincial capitals, and communities that were once difficult to reach. A journey that might require a flight in the United States can often be completed by train in China. Passengers enter centrally located stations. There is no long drive to a distant airport. There is no prolonged security ritual designed around international aviation. The train arrives, loads hundreds of passengers, and moves directly into the next city. But the most important achievement is not speed. It is the network. One prestigious rail line between two wealthy cities is impressive. A national system linking much of a continent-sized country is transformational. Once that network exists, companies can locate factories in lower-cost regions without becoming isolated. Workers gain access to more jobs. Tourism expands. Universities attract students from farther away. Business travel becomes easier. Smaller cities become connected to major economic centers. A railway is not only transportation, it reorganizes geography. This is where comparisons with the United States become uncomfortable. America possesses world-class engineers, successful freight railways, and extraordinary aerospace technology. But proposals for passenger rail frequently become trapped between fragmented authority, local opposition, permitting delays, lawsuits, rising costs, and changing political leadership. China's model is very different. Decisions can be imposed more quickly. Land can be assembled faster. Financing can be coordinated through state institutions. Construction can continue across political cycles. That system has serious disadvantages, including less public consultation and weaker protections for people affected by development. But when the objective is to construct physical infrastructure rapidly, it can be extremely powerful. And rail is only the most visible layer. The deeper story can be seen on China's roads. A decade ago, many Western observers treated Chinese cars as inexpensive imitations. Today, Chinese electric vehicle manufacturers compete on battery range, software, charging speed, interior technology, and price. Walk through a major Chinese auto show, and the number of brands can be overwhelming. There are compact urban cars, luxury sedans, electric vans, performance vehicles, and SUVs filled with screens, sensors, and advanced driver assistance systems. This competition is ruthless. Manufacturers introduce new models rapidly. Features that begin in expensive vehicles move into cheaper models. Companies that fail to improve can disappear. The result is a market where innovation is driven not only by government support, but by intense domestic pressure. China did not merely become the world's largest market for electric cars. It built the factories that make the batteries, motors, power electronics, and many of the materials inside them. That distinction is critical. A country can design a beautiful electric vehicle, but without battery plants, processed materials, component suppliers, specialized machinery, and trained workers, it cannot produce that vehicle economically at enormous scale. China concentrated these capabilities in connected industrial clusters. A battery company can operate near a vehicle factory. The vehicle factory can work with electronics suppliers. Those suppliers can access ports, highways, and logistics companies. Engineers can move between competing manufacturers. Improvements spread through the system. Costs fall. Production accelerates. This is what an industrial ecosystem looks like, and it is far harder to copy than a single product. The same pattern appears in solar panels, battery cells, electric buses, consumer drones, and increasingly in industrial robotics. China has become the largest market for factory robots, accounting for more than half of global industrial robot installations in 2024. Why install so many robots in a country once known for abundant labor? Because China is changing. Wages have risen. The population is aging. Factories must produce more advanced goods with tighter tolerances. And Chinese manufacturers are no longer satisfied with competing only through low cost. They want speed, consistency, and technical sophistication. Inside modern factories, robotic arms weld car bodies, move battery packs, inspect components, and operate through the night. Computer vision systems search for defects too small for the human eye. Automated guided vehicles move materials between production lines. Digital systems track performance in real time. The popular image of Chinese manufacturing as endless rows of low-paid workers is increasingly outdated. In many sectors, China is building some of the most automated production environments in the world. This creates an important paradox. Automation may reduce the need for some workers, but it can also help China retain manufacturing that might otherwise move to lower-wage countries. Instead of losing the factory, China upgrades it, and every upgraded factory strengthens the companies surrounding it. Then there are the ports. Ports are rarely included in glamorous technology videos, but they reveal more about economic power than many consumer gadgets do. At major Chinese ports, automated cranes move containers between ships and autonomous vehicles. Algorithms coordinate loading schedules. Sensors track cargo. Railways and expressways move goods inland. Factories can manufacture a product, place it in a container, and connect it to global markets through an enormous logistics network. This is the physical foundation of e-commerce, electronics, machinery, vehicles, and consumer goods. When Americans open a package containing a battery-powered device, a tool, a household product, or a piece of electronics, they usually see the final object. They do not see the industrial system behind it, the chemical processors, the component suppliers, the assembly plants, the warehouse robots, the container terminal, the shipping network. China's power lives inside those invisible connections. And this helps explain why moving manufacturing back to America is harder than reopening one factory. A factory does not operate alone. It needs suppliers. It needs tooling. It needs trained technicians. It needs logistics. It needs reliable demand. It needs companies nearby that can solve problems quickly. Rebuilding that network can take years. China has spent decades making it dense. The next layer of China's future is digital. In many Chinese cities, a smartphone has become an interface for daily life. Consumers use it to pay street vendors, enter transport systems, order meals, rent bicycles, book medical appointments, and access government services. The technology is not necessarily more advanced than systems available elsewhere. The difference is integration and adoption. In the United States, a consumer may use separate cards, applications, and accounts for different services. In China, large digital platforms brought many functions into connected ecosystems. This creates extraordinary convenience. It also creates serious questions about privacy, surveillance, market power, and government access to data. Any honest assessment of China's digital future must acknowledge both sides. A highly integrated system can be efficient. It can also become an extremely powerful mechanism for monitoring behavior. The same state capacity that helps coordinate infrastructure can limit dissent. The same digital network that makes payments effortless can give authorities visibility into citizens' lives. China's model produces speed, but speed is not the same as freedom. That distinction matters when people describe China as the future. The future is not only a collection of impressive machines, it is also the rules governing those machines. Who controls the data? Who can challenge a project? Who is responsible when a system fails? Whose home is removed to build the railway? Whose speech is restricted? Who benefits from the growth? These questions do not erase China's accomplishments. They make the picture more complete. China also faces major weaknesses. Its property sector has struggled. Local governments carry heavy financial burdens. The population is aging. Youth employment has been a concern. Some industries suffer from overcapacity, with companies producing more than the domestic market can absorb. Trade partners increasingly worry that heavily supported Chinese production could overwhelm their own manufacturers. This has contributed to tariffs, export restrictions, and a broader technology confrontation. So the Chinese model is not an unstoppable machine. It is a powerful system under pressure. And this brings us to the United States. Has America truly fallen behind? The honest answer is more complicated than any viral title suggests. America remains home to many of the world's most valuable technology companies. It leads in crucial areas of artificial intelligence, advanced software, cloud computing, aerospace, and semiconductor design. Its universities attract extraordinary talent. Its capital markets can fund high-risk ideas on a scale few countries can match. American companies often define the frontier, but China has become exceptionally strong at another stage of technological power: deployment. America may create the breakthrough. China may build the supply chain around it. America may design a revolutionary product. China may engineer a cheaper version, manufacture millions, and integrate it into everyday life. That difference is becoming strategically important. A technology does not transform society when it exists in a laboratory. It transforms society when millions of people can use it. The nation that controls production also gains knowledge. Factory workers discover problems. Engineers improve designs. Suppliers develop specialized components. Manufacturers learn how to reduce waste. Each production cycle creates experience that cannot be gained from a research paper. Scale becomes a form of intelligence. That may be China's most important advantage. Not that it always invents first. Not that every Chinese city is futuristic. Not that every project succeeds. But that once the country identifies a strategic industry, it can mobilize capital, infrastructure, suppliers, and demand around it with remarkable intensity. The United States once operated with similar ambition. It built the interstate highway system. It electrified vast regions. It created research laboratories. It sent humans to the moon. It developed aviation, computing, and the modern internet. America has not lost the ability to imagine. The danger is that it may be losing patience with the difficult, slow, and physical work required to turn imagination into national systems. A bridge requires permits. A railway requires land. A factory requires energy. A power grid requires transmission lines. A battery industry requires mines, processing plants, and chemical facilities. These projects are noisy, expensive, and politically difficult. But a nation cannot build a physical future using software alone. That is the lesson China is forcing the world to confront. The coming global competition will not be won only by whoever creates the smartest artificial intelligence model or the fastest computer chip. It will also be shaped by who can construct power plants, factories, railways, ports, and supply chains. China understands that technology is physical. America sometimes behaves as though technology exists only on a screen. But the most realistic conclusion is not that one country has discovered the perfect system. China needs more openness, accountability, and sustainable economic balance. America needs greater construction capacity, industrial depth, and long-term planning. China can learn from America's culture of experimentation. America can learn from China's commitment to execution. The future may belong to the country that combines both, the freedom to invent and the capacity to build. So when an American visitor looks at a Chinese high-speed train, electric vehicle factory, or automated port and says, "We are behind," what are they really seeing? They are not necessarily seeing a country that is more advanced in every category. They are seeing a country that made selected technologies visible, affordable, and ordinary. That is what creates the feeling of the future. The future does not feel futuristic because of one spectacular machine. It feels futuristic when the machine disappears into daily life, when the train is simply how people travel, when the electric car is simply the affordable choice, when the digital payment works without explanation, when the robot is simply part of the factory. China's greatest technological achievement may therefore be something less dramatic than a flying vehicle or an artificial intelligence breakthrough. It may be the creation of a system that repeatedly converts strategic ambition into physical reality. And the question for America is not whether it can defeat China in a single race. The question is whether it can remember how to build at the scale its own ambitions require. Because the next century will not be shaped only by the countries with the best ideas. It will be shaped by the countries capable of making those ideas real. Subscribe for more global technology documentaries. And tell us below, is China genuinely building the future? Or is the world overlooking the weaknesses beneath its extraordinary scale?